Developing Our Math Minds is a series of conversations and resources about math that is intended to be a journey of growth for families over several weeks. Each week, Minds lead mathematician and product director Brandon Smith and content development manager Nina Wu will be talking about the adjustments families are making to learning at home and the opportunities this situation provides for changing our relationship with math.
Well, thanks for coming in today. I can see on your resume that the last time you did school math was a decade or two ago, and it seems like you don't even like math that much, or you might be a little math anxious, and that you don't even really want this job. But perfect, you're hired. No, but really, I think a lot of people in this unprecedented time are being asked to be an ad hoc teacher for their child or children, specifically a math teacher. That might be really daunting. And I know it's been a while since a lot of people have thought about math outside of taxes and bills. So maybe some things have changed in the landscape, and maybe your kids or teachers are coming at you with all these new math terms. So I thought I'd just make a quick little video to kind of give you a rundown of some new terms, and really they're things that you already know, just little fancy names for them. And so no worry, no stress, and it'll be a moment for you and your child to learn together. The first big idea is modeling, and what we mean by modeling, it's a very general term, is just visually representing a situation. Most simply, draw a picture. The most common pushback I hear from students is, I can't draw. You don't need to be a good drawer. You just need to be able to do some stick figures, boxes, lines, dots, circles, to just get the conceptual, muddy, numeric mess in your brain down onto paper into a visual representation. So there are many more specific modeling tools that your students might be asked to use or would be helpful for your student to help them problem solve. And the first one is an array. An array is a way to organize objects into a grid. So for example, if there was like a word problem or a math problem that was like 5 times 3, 5 groups of 3, you could just make a simple little array, 2, 3, 4, 5. It doesn't have to be super neat or whatever, but you can see how an array helps you organize information, and you can show like the commutative property of multiplication, for example. Like you could either count these columns or the rows, and both are fair. An array is good for countable objects. You wouldn't want to spend time drawing like 60 things in an array. A more broad version of an array is an area model, which is kind of the same thing. It's just an extension used for larger numbers. So for example, instead of 5 times 3, maybe it's 15 by 30, and so then I can call it literally an area. And I can call this 15 by 30. Other times, students can break this up into other buckets where 30 can now be broken down into 3 tens, and this is like 10 and 5. It's a method to do multiplication sometimes, or just to model different math situations. So area and arrays are very related. Another tool for modeling is a number line, and I think everyone knows what a number line is, but maybe the way that they're being used now might be a little different than what you're used to. You can use it for like skip counting or just problem solving. If I'm asked what is the difference between 14 and 41, like I know I can jump by tens. That'd be 24, 34. Okay, well 44 would be here, so that's where I am. And then so 34, 35, 36, 37, 38, 39, 40, 41. So this isn't to scale, but you can see how this is, and I can count my humps. 1, 2, 3, 4, 5, 6, 7. So I can see that the difference between 14 and 41 is 27. Number lines are good for distance, skip counting, and it's really good for like addition and subtraction type of problems. Another, maybe a new word for some parents I've heard, to help with modeling, you could always use manipulatives. Manipulatives are simply physical objects to help you model and count things. They are tangible. You can manipulate them with your hands, and more than anything, they just need to be uniform with each other. You can make your own or find some around the house. I made these examples. Pasta you probably have lying around, dry beans, coins, blocks like Legos or something, paper clips, office supplies. Or you can make your own paper squares, for example. To make these less flimsy, I took multiple sheets of from a magazine and glued them together, and then I cut out squares. It could be a good activity you give to your child to, learn precision and handiwork. Yeah, there's no need for you to go out and buy anything, and it's really just helpful to have students touch math and interact with it and feel and manipulate it, which is why these are called manipulatives. And then within manipulatives, you could sometimes use unit tiles, which is more like these. What's important about unit tiles is that they need to be the same size as each other, because a lot of times they're used for measurement problems or area problems, or even they can help model fractions. It's important that they are the same size as each other to keep true to the math. So they have to be made a little more precisely, but they're great tools that you can just easily make at home. So outside of modeling, your students might be dealing with mental math. And yes, this means the math we do in our head, but the purpose and the strength of mental math is not necessarily to be able to calculate exactly what's in your head. We have calculators for that. But really, it's an estimative tool to get a ballpark for what you think a sensible answer would be around. So, for example, for a problem like 468 minus 139, use your mental math to kind of get a reasonable estimate for what your answer should be around when you actually execute the math. So I know it's 400 something, 100 something. The answer should be 300 something. And that checks out because I'm subtracting, so the answer is less. But, oftentimes students will get bogged down in the weeds of the algorithms and the calculations, and they'll come out with a bigger answer or an absurdly small answer, but it's because they didn't apply the mental math and the reasoning of the sense making of what numbers mean. And that's why in school we work on mental math. It's really for estimating and reason making rather than direct calculation. We have calculators for that. To support mental math, you have what's called fact fluency. Depending on the age of your students, for younger students, it's knowing your sums to 10, just knowing that 7 and 3 make 10, 6 and 4, 5 and 5, 2 and 8. You should know that deep in your being, and that will really help set your student up for success later on when they know the different decompositions of 10. What helps with that are 10 frames, and those are simply, it's an array of a 2 by 5 grid, and you don't need to print these out. You can make these like that, and they can help. If I filled in 2, you should know that the difference, how many are left, and you can make flashcards of those. Your students can draw those, but that's a helpful modeling tool, our 10 frames, to help with your sums of 10 fact fluency. Another version of fact fluency are your multiplication tables, which I'm sure we all have memories of. Yes, we have calculators and things, but sometimes having that strong foundation of just knowing your facts off the top of your head will help you get a long way. And so to break that down, just means being fluent with your facts. The next term is Numbersense. And all that means is, do you understand what numbers mean and what operations do to these numbers? Adding 2 numbers makes it bigger. Subtracting 2 numbers makes it smaller when you're dealing with positive integers. How does multiplication and division affect these numbers? And what's the difference of magnitude between ones, tens, and hundreds and thousands, and understanding place value. And place value is the difference between ones, tens, hundreds, so on and so forth, and knowing that each one is made of 10 units of the former. We work in a base 10 system, meaning every units of 10 we add a new place value. That is the basic building block of math literacy and numeracy. The next term that might be new to you is friendly numbers or benchmark numbers. And these are numbers that you can work with. They're often your tens or your fives or your hundreds. They're numbers that you would round to. They help you estimate and land in a safe, comfortable place that you can work on and hold. And I think, as adults, we often do this in our own minds, use our friendly numbers and benchmark numbers, but for your students, we've given names for them. And finally, regrouping instead of borrowing. So this is, I would say, the more conceptually correct term for borrowing. In the traditional subtraction algorithm that a lot of us know and grew up with, it trips up many students. Why did we cross numbers out and make them little? What are we borrowing? Why is it called borrowing? Really, it's just shorthand notation to show that we were really regrouping. Let's say we have this problem, 43 minus 19. And traditionally, we would do this thing. And it's like, what the heck does this mean? What are you borrowing? So now what we're really doing, it's the same math. It's just different words to better conceptually support it. So when we cross this out, what we're saying is we're turning this 40 into 3 tens, and we're adding a 10 to this 3. So we're turning 43 into 30 and 13. Keep this 19 as 10 plus 9. What we did was we regrouped. We took a 10 and turned it into 10 ones. We're not borrowing, we're just reshifting how we're decomposing this number. So still, 13 minus 9 is still 4, and then 30 minus 10 is 20, and so really the answer is 24. Same math, same answer, it's all the same under the hood. All we're doing these days is giving our students more conceptually accurate language in hopes of building a more math literate generation. So that's the 101 on regrouping. I mean, if you still want to call it borrowing, go for it. Just know that that's what we're doing. Hopefully that was a helpful, quick little rundown of some of these new math terms as you're stepping in to be your child's new math teacher. And I would say, don't stress too much. Don't let your traumas from math in your childhood deter you or, pass down a fear of math to your student. You can be a student right along with your child learning math together, and they can maybe teach you. If there's frustration, take it on together. And there are endless resources on the internet or neighbors or maybe at a 6-foot distance, but you can call people up, you can look on the internet, you can figure it out together. This is a great opportunity to bond with your child and maybe even, rewrite history for yourself and form a positive relationship with math. Yeah, so good luck on the job, and I think you're going to do a great job. Have fun!